Hi, today we will learn about logarithm properties. Okay, properties of logarithms. Okay, so let's write it down here. Properties of logarithms. Okay, so what are properties? Okay, maybe now onwards you will be learning these properties of atom, properties of what is that? Electron, properties of proton. So we learn a lot of properties in this one. What are properties? Just to understand what it is. Those are all properties. So some derived theorems or something like, okay, we learn them. So don't get what to say, it is something we make our lives easier. Okay, so why we are writing all these things? Okay, let's get into this topic, and we learned already these things. A to the power of m multiplied by a to the power of n equal to a to the power of m plus n. Okay, we write all these things. Why we are writing all these things? So have you questioned yourself at least once? So basically this make our job easier. If you, like for example, like 2 to the power of 2 cube and 2 to the power of 4. So if somebody asks this question, yeah, we can do like 3 times, and here 4 times. So because bases are same, right? A. So here we can do like this: 2, 4, 8, 16, 32, 64, 128. We can do like this. So, and if we write it as 2 to the power of m plus n, then it becomes 3 plus 4. That also 2 to the power of 7. If you write it 2, 3 times 4, 5, 6, 7. This is also 128. So this is nothing but 2 to the power of 3 plus 4 and raw square. So I mean, you can write it like this, and it will become 2 to the power of 7. Why we are writing all these things? So to make our job lives easier. There is no other logic or anything. So we can write 128 also. Why we are writing all these things? 2 power 7. To make our job lives easier, like okay, if you want to do 2 to the power 2 cube and 2 to the power 4, so you can do all these things. So for example, like okay, when you might have seen like in chemistry some constants. Forget about all those things. What is the at what speed light travels? So we know, right? What is the light speed? Speed of light. Light travels at 3 into 10 to the power of 8 meter per second square. We always write this one. Why can't we write 10 to the power of 8 as 1, 2, 3, 4, 5, 6, 7, 8? So that is nothing but 1, 2, 3, 4, 5, 6, 7. Yeah, did I write it correct? Hope so. So why can't we write like this? How much space it is taking? This much space it is taking. Rather, it is very simple to write 3 into 10 to the power of 8 meter per second square, right? So that is the convention we are using. If somebody writes like this, okay, nobody says like, okay, you wrote a wrong answer. Teacher should give marks for this one too. But you see the space and the way we understand, easy to understand, 10 to the power of 8. So, okay, if you remember, always I have to remember like, okay, 1, 2, 3, 4, 5, 6, 7, 8, or else I have to count it like this. What is this? 30 crores, huh? Yeah, 30 crores meter per second square. It is not easy to speak, easy to write. So that's the reason we always go with this exponential things, and 10 to the power of 8 we easily write. That's all convention. There is no logic in this one. If you want to write it like this, you can write it. No. But if you want to write it, so we made some like, okay, simplifications. Like, okay, oh, this is if a to the power of m and a to the power of n, if these two are multiplied, product of these two, then you can simply add it. So we proved also. It's kind of our convention and understanding. There is nothing else. So based on this one, we have what to say, properties of logarithms. So for easy calculations, we made few things and we are going to learn them. Okay, the very first property what we got in our book is that multiplication product of two numbers. Okay, I will write it down. So yeah. Hi everyone. So hi, this is the first theorem in the logarithms. So what we found is like theorem product rule. Okay, let me highlight this one, product rule. So we know product. So something multiplied with something is called product, right? So what is that something something? So we are learning about logarithms. You might have guessed it already. So product of some logarithms, or something about product and logarithms. Let's see. So the proof is very simple. But before getting into the proof, we have to understand the theorem, what they are trying to say. Okay? That is more important. So people try to just jump into the proof. Okay, this is this. The two-line solution, they say like, okay, oh yeah, we did it. No. we have to understand the theorem, what they are trying to say here. So he is trying to tell there are three positive numbers, a, x, y. He is highlighting positive real numbers. So real number means it is even rational numbers also, it can be a real number. So it is not only integers, 1, 2, 3 are integers. It's not only integers. He is talking about real numbers, even 0.1, 0.2, and even the irrational number square root 5, square root 13, and all these things comes under real numbers as long as they are positive, not negative. Positive. 0 is not positive, not negative. So he is trying to tell that so above 0 and not equal to 1. So we already learned why a can't be 1. So we already explained with the graphs and other ways. So a can't be 1. So positive means not included 0, and he didn't include 1 with a special condition with a not equal to 1. He wrote it specially. So this is all what he is trying to say in this statement. Let a, x, y be positive, no 0, real numbers. So it could be any of these numbers, and a special scenario, a not equal to 1, then only this applies. Prove it. That's what he is trying to tell. Okay, let's write that one and write the proof. Okay. Okay, let's take so we already explained, we already know a to the power of n multiplied by a to the power of n equal to a to the power of m plus n. We know this one already, isn't it? So let's do this exponential. So let's go by the exponential and logarithms, right? So every time when we see a to the power of n, I keep repeating this word called this is exponential, so that it will leave some kind of an impression in your brain that, oh, if you see a to the power of n, oh, this is an exponential. That is kind of a thing what I am expecting from. So whenever you see that a to the power of m, then you have to think like, oh, it is exponential thing. Okay, a to the power of n, it is some kind of exponential. Let's call this as x. Okay, then what is m? Logarithm of x base a, right? Then a to the power of n equal to y. If you take this one, then n equal to log y base a. Oh, okay, I forgot to. So we know that, right? So when a goes on the other side, it will become like this. So you have to think, when multiplication on this side, on the left side of equals, it goes on the right side, it becomes divided by, right? Just same thing. When m goes here, a goes here, then log x base here. It's another kind of a convention we do. Like when multiplication goes on the other side, it will be division. addition on the left side, it will go to the other side, it will become negative. It's the same thing. If it is on the exponential, so if it goes like this, then it will become log x base a, and the similar way here. So we write these things. Okay. Yeah. So we already know that a to the power of m multiplied by with a to the power of n equal to a to the power of m plus n. So let's write the same equation again one more time. A to the power of n multiplied by a to the power of n equal to a to the power of m plus n. We know this. This is a fact. But we let a to the power of m equal to x, right? So this is x. A to the power of n equal to y. So we wrote it here. This one we wrote it here. Then to the power of a to the power of m plus n. So this is nothing but xy equal to a to the power of m plus n. If you write logarithm of this one, a to the power of m plus n equal to xy. Then if we push on the other side of the equals, it will become m plus n equal to log xy base a. What is m? Log x base a. What is n? Log y base a. Equal to log xy base a. So we proved the statement. Good. Why, or to say hence proved, okay, whatever you want to write, we can write hence proved. Good job. But why we need it? Why we are giving special importance to this product and these things? So in real life situation, we will be running into many questions like this. I'll show you. Yeah. When we grow up, where we use logarithms? So mainly in chemistry and some physics problems, I don't know, but I used logarithms in chemistry more. So when you grow up, when you go to intermediate or engineering, so there you use this one, logarithms. So the uses. Sometimes we need to figure out a product of something like 2.023 multiplied by 5.055. How we do in regular calculations? We multiply like this. I will do 5 3 is 15, 1, 10. And 5, 10, something like this, right? Then again you have to write something, then you will add everything, then you will get the multiplication. It will take a lot of time. So now itself I feel like very lazy to do this one. So if you have a calculator, then you can do it faster, but that is not the intent here. So sometimes in some examinations they don't allow calculators, and not only that one. So in old times they use logarithm tables when calculators were not available for everybody. Nowadays calculator is available to everybody, but yeah, that's a different thing. Where we use logarithms, and logarithms make our job simplified in many ways. So what we do, we apply logarithms. When you apply log, it will become log of 2.023 multiplied by 5.055. So we take the value of x. We'll think this is x and we'll put log x. We apply log on both sides. Then log of this product, it becomes log of 2.023. So when I'm not writing base anything, means it is common logarithm base 10. Please understand that one. This is log, like understand this is p and this is q. Log p q. We can write log p plus log q, right? So I'm writing log p log q log x. If I use the logarithm tables, I get the value of this one directly. Something like 0.4 4 something. This is a random value. Don't say that okay sir, you wrote some wrong number there. Then it will be like some 0.51. So once we derive these values, it will become simple. Like we just need to add. Addition is simpler than multiplication, right? If you agree to that point, like we can proceed. Then it will become like log 7, 5, something like that. But it is not x, it is log x. Then what we do? Anti-logs, 0.75. It's another thing, then we will get the value, exact value we get it. This is the purpose of understanding this theorem, product rule. So all these things, and we are applying common logarithm means it is not equal to 1 and it is a real number, it is a real number. Everything is okay, it is following the rule. So that's the reason we apply this one and get the values very simple. That is where we use this multiplication. I hope you understand. We'll see the next property shortly. Thank you. Hi, let's learn quotient rule. So it's a second property of logarithms. So the theorem is same like product. If you understand the product, so this quotient rule also we follow the same thing. A, X, Y are B positive real numbers. I explained you the meaning why they have to be positive and why they have to be real and why any are not equal to 1. Why positive, why not, what to say, that means it is not 0. So all these things I explained in the other one. So the only difference is earlier we used x, y, that means product of two numbers. So here x divided by y, it's a division. So quotient rule. So we follow the same principle like okay, we already know. So proof. So this proof is depending on another proof we did in the past. A to the power of n divided by a to the power of n equal to a to the power of m minus n. This we learnt in the previous classes. So that means in your 8th grade or 9th grade you might have used this one. So this we proved. Using this, so we don't prove this one again. So that is what theorems do. One theorem uses the other theorem to explain this theorem. Okay. So in order to prove theorem, okay, it depends on this theorem. We might have studied this one in your previous classes. So it is proven. Since it is proven, we can use it in our theorem. That is what it means. So if you don't understand, probably okay, this is all based on this theorem. So you can go to your other classes to learn this one. But so for this theorem, we'll take this on the basis of this one, we continue. Since it is already proven, we don't prove in this theorem. Okay. So we follow the same thing. A to the power of n, we call it as x. Then m equal to, it's all rotation. If a goes on the other side, it becomes log x base a. Then a to the power of n equal to y. Let. All these are lets. Then n equal to log y base a. Good. And we'll take this one. What happens? This is already proven. A to the power of n base a divided by a to the power of n equal to a to the power of m minus n. This is proven. So a to the power of n is x. Let's put x. A to the power of n is y. Replace this with x, this with y. Then a to the power of m minus n. We can also write a to the power of m minus n equal to x by y. So this continuation of this one is here. Then how we can write m minus n equal to log x by y, not x base y, x by y base a. We know what is m. What is m here? M equal to log x base a minus n is, I'm copying this from here, this from here, log y base a equal to log x by y base a. We prove this one. So that's what it means. So why we use it? So I already explained if we multiply two numbers, how it helps us. So in the same way, if we are dividing like 2.055 divided by 5.033, so this is division. In order to do this division, it takes a lot of time. If we apply logs like product, it will become a subtraction of it, easy to do. Yeah, it will get the same result. That's the reason we apply logarithms here. That's the second theorem. I hope you understood. So this theorem is based on this principle. So we use this principle and we derive this one. Okay? Thank you. Yeah, let's read the power rule. I just erased a few words here and made this statement. So theorem, power rule. What it is? The same thing. These conditions never change. So a, x, y be positive real numbers with a not equal to 1, then a to log of x to the power of n base a is equal to n. So it is nothing but, if you observe closely, n came here as a product. So we became like n multiplied by log x base a. So to the power n came here. That is what we are trying to do. So here if you see, yeah, so if you observe closely, the n came here and that is what we are trying to do. So to the power n, okay, if we can easy or to say, rather figuring out x to the power of n value, it is simple to multiply. If you find out the value of log x base a, just multiply with the n, it's the same value of this one. That is it is making our lives easier. That's all about. If somebody wants to do, I want to do this way, nobody would object. They'll let you do that one. So learning all these principles is make our job easier. That's it. And this is also based on a previously explained principle. So that is a to the power of n to the power n is equivalent to a to the power of mn. So in order to prove this one, we depend on this one. This is already proven, we don't prove again. So that's the intent of it. So since it is already proven, we can take this as granted and we'll go further down. So as usual, we'll take a to the power of n equal to x, let then m equal to, if a goes on the other side, m comes down, a goes on the other side. This is a simple way to understand. It becomes log x base a, right? So since we already know this one, we'll write the line again. A to the power of n to the power of n equal to a to the power of mn. So we know a to the power of n, we already let a to the power of m equal to x. So x to the power of n equal to a to the power of mn, right? So we can also write a to the power of mn equal to x to the power of n. So what is mn? Again we do logarithms on this one. Mn equal to log x to the power of n base a. Okay? The continuation of this one goes here. Mn equal to, I'll write the statement again. Mn equal to log x to the power of n base a. N, m, I'll write n first and m second. Log x to the power of n base a. What is m? I'll go write that one here. Log x base a equal to log x to the power of n base a. Hence proved. So we got this statement. Why we use this one? If somebody asks us to do log to 10 to the power of 4 base 5, we can immediately say 4. 4 because 4 comes here, and log 10 base 5. If you know the value of log 10 base 5, if we multiply with 4, we get the value of this one. Rather figuring out log, this is 10 cube, 10 to the power, log 10 to the power 10,000 base 5, rather figuring out this value, we simply know this value, multiply with 4, you get the value. That's the intent of this one. So it will make our jobs easier. I'm repeating these statements just because these properties, what is the help of all these properties? It is make our maths easy. That's it. If you want to, somebody wants to do this one, I don't want to do this one, go with this one, you get the same number what we are doing here. Yeah. With that, we completed the properties of logarithms. I hope you understood very well. Thank you so much.